In the first part of this problem, we are asked to find the period. And so a note is that for sine, cosine, secant, cosecant, the period formula is 2 pi over absolute b, because those graphs complete their cycle in 2 pi. For tan and cotan, the period is pi over absolute b, because they complete their cycle in pi. So for number 15, I'm going to do 2 pi over b is the coefficient of x, so over 1/2. And that's going to be 2 pi times 2 over 1, so that's going to be 4 pi. In number 19, period is pi over absolute b. Coefficient of the x, in this case, is 1/3. So pi divided by 1/3 is pi times 3 over 1, so that's 3 pi. So those are the periods. To find the phase shift, we take what's inside the trig function. So for number 15, that's 1/2 x. And we set it equal to 0 and solve. So for 15, 0 is the phase shift. And for 19, if we take what's inside the cotan and set it equal to 0 and solve, that'll get us our phase shift. Divide both sides by 1/3 and get x minus pi over 2 is 0. Add pi over 2 to both sides. Phase shift is pi over 2. The last thing we wanted to talk about here was range. And if you think of the graphs of tan and cotan, they look like x cubed. So the range would be all reals. And if you think of cosecant and secant, they are parabolas. And one's up and one's down. So there's going to be a negative infinity and an infinity, but then there's a space in the middle. So we're going to do negative infinity, 2, and then the parabolas are going to start at the A and opposite of A. So it's going to be at 2 and negative 2. So I'm going to do negative infinity to negative 2, or 2 to infinity. And the peak and valley of the parabolas will be at 2 and at negative 2. So actually here I need a square bracket around my negative 2, and I also need a square bracket around the 2. So my range for cosecant is negative infinity to negative 2, or 2 to infinity.